All right, let's try a little more challenging algebraic one. You're going to get a whole variety. You'll get quadratics. They tend to be pretty quick and easy. You need the same algebra tricks you did for difference quotients. You'll get radicals, in which case you need to multiply by the conjugate. You'll get rationals, in which case you need to clear fractions. So this is a fairly messy rational. So I am going to start right off with clearing the fractions, which means I need to multiply by the LCD, which in this case is just the product of the two denominators. So I have to multiply by both of them. That's my LCD. And if I do it to the top, I'd best do it to the bottom as well, or I've changed the value of this fraction. Okay, so that's my step. Please be careful with your notation. I won't always be super picky, but this is one place. It's the same with the definition of the derivative, which is coming up, where I will be picky. I want to see you use your notation correctly, and part of that is that it shows me that you understand when the limit happens. So we will write the limit down until we evaluate it, and evaluating it means actually getting to plug the 0 in for b. We can't do that right now. I didn't do my check ahead of time, but we can't do that right now because if b equals 0, then the denominator is 0. And just for our own curiosity, if b equals 0, the top goes to y over y squared plus 1 minus y over y squared plus 1, which is 0. So this is a 0 over 0 limit. So algebra is a great thing to try. Make sure you're distributing this entire LCD through. When we multiply that first fraction, oh, if I haven't said so, this is algebra we've already been doing in the last couple of sections. So pause and try this one and then come back and see how you do with the algebra challenge. Okay, so as we multiply the first fraction, the y plus b squared plus 1, this entire factor right here, cancels out. We're left with the y plus b from the numerator, and we're left with the y squared plus 1 from the LCD. When we multiply the second fraction, the y squared plus 1 cancels, but we still have the minus, we still have the y from the numerator, and we still have the y plus b squared plus 1 from the LCD. In the denominator, don't go multiplying things out. This is actually in a great form. The denominator, when we do this, is truly a product. This is, the big operation is multiply and multiply, which means we could cancel out of that at any time if we free up the right stuff from the top. We particularly want to cancel out this b so that we can plug 0 in, but anything from the denominator, we could cancel out this entire chunk, this entire chunk. That is not true from the numerator, so don't fall into the temptation to cancel one of these two out. The big operation in the numerator is subtraction. You cannot cancel out of a subtraction problem. So we have the unfortunate task of having to multiply everything out in the top in hopes of being able to regroup and get something factorable so that we can factor a b out and cancel, or even factor a y squared plus 1 out and cancel, some kind of canceling. This first chunk, I'm going to go ahead and FOIL that out. So I get a y cubed, y, a by squared, and a b, in whichever order, depending on how you look at that, but you should have all 4 of those terms. For the next part, I'm going to distribute and make sure that, in fact, I'm going to do a little bit of pre-work before I distribute. The y plus b squared, that means y plus b times y plus b. Make sure you don't just square the y and square the b. You should FOIL that out, and there should also be a 2by b squared. And I'm going to write the plus this plus 1 up there as well so I don't lose it. So I want to multiply all of that by the negative y. So I get a negative y cubed, a negative 2by squared, a negative b squared y, and a negative y. Big and long, but this next step is the fun one where you get to cross a bunch of things out. So let me just jot down this denominator once again, and we'll start looking for those. I see a y cubed, and one of them is negative, so that adds up to 0. I see a y and a minus y, that adds up to 0. None of the rest cancel, but I do see some like terms. I have a plus by squared minus 2by squared. So I can combine those. So let me just write this again. Okay, so I'm left with a plus. Okay, so a negative 1by squared when I combine those two. The plus b right here, so I got these two. And the minus b squared y at the end. And then rewrite your whole messy denominator. I know it's a pain, but I want you to be able to keep track of all these pieces. Now we're getting towards really key steps. We've simplified a ton. Our big hope was to cancel out this lone b so that plugging 0 in doesn't make the denominator 0. I will be able to do that because every term on the top has a b, so I can factor a b out. It will leave me with a negative y squared plus 1 minus by. And my favorite thing to write out, this entire denominator yet again. Okay, cancel the b, the magic is happening. Once that b is gone, you can finally evaluate the limit, because with that b not there, plugging in 0 will make some things 0, but it's not the entire denominator, and that's what was a problem. So I will not write the limit anymore because it's happening. I'm left with a negative y squared plus 1 on the top. When b becomes 0, this is 0 times y, which is 0. On the bottom, I'm left with the, okay, so y plus b squared, this becomes just y squared because the b is 0. So it's a y squared plus 1 multiplied by another y squared plus 1. So we can just put a square there. So that is where you should end up. I hope you had some luck at least getting close on that one. It's really good practice.